Hi, this is Kona, and we're going to talk about probability. Remember, though, this is just a supplement to what's in the text and also what's in the online class notes. So, probability rules. So, first of all, probability is the chance that something will happen, right? So, the rules for the chance that this will happen include all probabilities must be between 0 and 1 inclusively. 0 and 1 is this would be obviously in decimal, so 0.5 is 50%, 1 is 100%, so that's where you sit here where it says you can't have less than 0% chance or more than 100% chance. That's because the 0 is the 0%, the 1 is 1 times 100, your 100% chance. So probability is between 0 and 1 inclusively, but it also can be considered between 0 and 100%. The sum of the probabilities of all the different outcomes must be 1. So if you include all of the different possibilities and you add them together, if there's no duplications, then they have to add up to 100. A probability of 0 means something cannot happen. So literally if it's 0%, then it's 0%. It can't happen. But do keep in mind once we start using Minitab that sometimes Minitab will round to 3 decimals and it may appear that something is 0 and it's just actually really small. So it's not that there's 0% chance of it happening, it's just really small. Probability of 1 means something is certain to happen. So 1 is that 100%, and there's a 100% chance means that it's really, really close. It's going to happen. The probability of something not happening is 1 minus the probability of it happening. So if there's a 10% chance of snow, then there's a 90% chance it won't snow. If the probability that no one will attend church is 0.05, then the probability that at least one person will attend church is 0.95. This type of situation is called a complement, and this is really important because that complement means it's going to be kind of the opposite piece, that piece that helps it add up to the 100% or to the 1. And overall, probability is just the number of successes over the total number of trials. So, to try some problems, we're going to do simple probability first. Simple probability is when you're just dealing with one thing, so one possible item is chosen. Simple outcomes occur when only one thing is chosen, so just one thing. So here we've got a bag containing 12 $1 bills, 8 $5 bills, 3 $10 bills, 2 $20 bills, for a total of 25 bills. So in this case, what is the probability that a randomly selected bill will be a $5 bill? So remember, it's number of successes over number of trials. Well, a success would be drawing a 5, so there's 8 chances of success over 25 possible chances. So 8 over 25, divide that out, is 0.32 or 32%. What's the probability that a randomly selected bill will be a 10? Well, there's 3 $10 bills, so 3 chances of success over 25 possible. So 3 divided by 25 is 0.12 or 12%. What's the probability that a randomly selected bill will be a 1 or a $5 bill? Well, for that one, we've got 12 $1 bills and 8 $5 bills. So you add those together to get 20 bills that are either a 1 or 5. And so those are your chances of success divided by our 25 chances, which is our 0.80 or 80%. What's the probability that a randomly selected bill is not a $5 bill? Well, since there's 8 $5 bills, and you just take the 25 total minus 8, that means there's 17 bills that are not $5. So you've got a 17 over 25% chance, which is 0.68 or 68%. So those are your simple probabilities. Now your compound probability rules is when you're doing more than one thing at a time or more than one thing. So it's not just one thing and that's it, it's more than one thing. So for the probability rules here, the probability of 2 or more events all occurring is the product. Remember, product is multiplication of their probabilities. So if the probability of flipping a head on a coin is half, 1/2, then the probability of rolling a 2 on a single die is 1/6. Because you remember here, flipping a head, you've got a 1 and there's 2 possible, his head or tail. A 2 on the single roll of dice. Well, the 2, there's only 1 2 on a dice, and there's 6 numbers on a dice, so that's where you get the 1/6. And the probability of doing both is 1/2 times 1/6, which is 1/12. This is sometimes called the multiplication rule because it involves multiplying the probabilities together. The probability of one or another event happening, so one or another event happening, is the sum of their probabilities. So if there's overlap between them, then you have to subtract since you don't want to double count it. So in this case of our example before, but this time we're trying to find the probability of one or the other happening. So the probability of flipping ahead or rolling a 2 would take that 1/2 plus 1/6, because remember we're adding it, but then we have to subtract the 1/12. And remember that 1/12 is a chance of doing both. So we add the two probabilities of them happening, subtract it by the 1/12, which is them happening together, because that's the overlap, and we get 7/12. This is also sometimes called the addition rule because it involves adding the probabilities together. The probability of at least one is 1 minus the probability of none. So at least one is not none, they're complements. We know everything has to add up to 1. So for example, if there's a 5% chance it won't snow for any of the next 10 days, then there's a 95% chance it will snow at least one of the next 10 days. So those are our compound probability rules. And then let's look at our compound probability examples. First of all, we've got an example of 2 bills with replacement. So the difference from the previous simple example, the simple example was 1 bill, but now we're dealing with 2 bills. The first one is going to be with replacement. So that means we're going to pull 2 bills out, but when we pull the first one out, we're going to put it back in before we pull the second one out. The other one is 2 bills without replacement. So in this case, we're going to pull one out and leave it out and then pull another bill out. So up here for this one, so a bill is drawn from the bag and replaced, contents of the bag are mixed up, and a bill is drawn for a second time. So since the first bill is replaced, the probabilities of getting certain bills for the second time are the same. And this is important. The probabilities of getting a certain bill for the second time are the same as they were the first time. So this is a classic example of independent events, because whatever happens the first time doesn't impact what happens the second time. So find the probability that both bills are $1 bills. So the probability that the first bill will be a 1 is 12 over 25, because here we've got this is our success over our total. So the probability that the second bill will be a 1 is also 12 over 25. So this means the probability that both will be $1 bills is 12 over 25 times 12 over 25, which is your 144 over 625, which is your 0.2304 or 23.04%. So find the probability that the first bill will be a 5 and the second bill will be a 10. So 8 over 25, there's 8 $5 bills over 25 possible. And the 10, there's 3 chances of success for getting a 10 out of 25. So 8 over 25, 3 over 25, you multiply those together to get 24 over 625, which is your 0.0384, which is your 3.84%. So the 2 bills with replacement is pretty straightforward. So now let's take a look at the 2 bills without replacement. So in this example, a bill is drawn from the bag and not replaced. A second bill is then drawn. This time we're not replacing the first bill, so it affects what's in the bag when we go to draw the second bill. These are called dependent events because what we get the second time depends or is affected by what we got the first time. It also means the probability, or this total, goes down. So if we take a bill out and we don't put it back in, then this total goes down to 24, not 25. So find the probability that both bills are $1 bills. So this time it's without replacement. So since we took the $1 bill out and didn't replace it, there's now only 11 $1 bills out of the 24 bills. So the probability of getting both is the product of the probabilities. So we still have our 12 out of 25. We still have that 12 out of 25. But then when we get down to the next one, well, we already have the 1 gone. So we only have 11, not 12, because we already pulled a 1 out. And we also only have 24 total chances. So this is where the 11 over 24 comes from, because we pulled one of those $1 bills out. So we don't have 12 in the bag anymore. We only have 11. And that means we also only have 24 bills total. So that's, once you divide it out or multiply it, you get 11 over 50. Which is that right? Maybe once you divide, oh, that must be once it gets simplified down to 0.22 or 22%. Let me double check that math really quick. Okay, sorry about that. I had written this out earlier in the week, and I just wanted to make sure I didn't make a mistake on my math. But that is correct, even though this might look incorrect. I must have already simplified after I did the multiplication. I must have simplified, but it is 0.22 or 22%. And then the last problem is find the probability that the first bill will be a 5 and the second bill will be a 10. So in this case, our first is a 5 and that's our 8 right there out of 25. So that's our 825. But then our second bill will be a 10. Well, we still have 3 10s, right? Because we haven't taken any 10s out. So the 3 will stay the same, but this total is now 24 because we've taken a bill out. So 8 over 25 times 3 over 24. This must be the simplified version, but then it's 0.04 or 4%. So here is just kind of your brief, this is probability, simple probability, and some compound probability examples, and I hope it helps.